This is Aurora with the Central Coast Astronomical Society, and we are so excited to do our presentation for you tonight. We are going to be doing some live stargazing. Our goal is by the end of tonight's presentation, you can go outside as long as it's not raining and you can see the stars. You'll go outside, look up, and you'll know what you're looking at and you'll know where to look. And so we are going to be focusing on naked eye objects, binocular objects, and also we've thrown in some 8-inch telescope objects just for those of you who have a telescope. So it'll be a good mix for tonight. There is a handout. If you have it, we're going to go through it step by step. If you don't have the handout, please don't worry. This is just something a little extra after the session that you could download that highlights what we had talked about for tonight. We actually have a quick presentation we're going to do before we get started, and we have an astronomer who's with us from Riverside Astronomical, and I'm really excited to bring him on board while we're getting things started. And so he's going to start us off with a quick 3-minute presentation. When he heard we were doing our stargazing, he said, "What objects are you doing? I will go out." This was last month, and he says, "I'll go out to my observatory and I will image something just for you guys." And not only that, he put together a really, really quick little, he wants to present a few little details about it. And so you get to see him and his telescope right now. He took some shots of it. So I want to introduce him, and then we'll come back, and then you'll be able to meet our astronomers for tonight's show as well, other astronomers. So if you wouldn't mind, go ahead and anytime during this presentation, do you see the link at the bottom? Write this down on your sheet or write it down because it's going to disappear. It's only here in the very beginning. So during our presentation, if you have any questions at all about anything that we're talking about with astronomy, your best place to put those questions is you're going to put it in the chat box. And because we have several astronomers that are on right now that are answering those questions for you. And then if you don't have access to chat or you're viewing us a different way, and go ahead, you can send us a text or an email. You can email questions at centralcoastastronomy.org. And the phone number, you ready? I'll say it out loud twice, 805-242-6415. So 805-242-6415. Or you can just send us an email, Aurora, questions at centralcoastastronomy.org. I'm always used to saying my own email. So the email again is questions at centralcoastastronomy.org. And we'll be monitoring that throughout tonight's session, which should be about an hour, maybe a little bit more, maybe more like 70 minutes. But you guys ready to get started? Okay, so let me bring on our first astronomer. Okay, his name is Alex, and he is super excited to be sharing a special event, a special object that we're going to be talking about a little bit later in tonight's show. But we're just going to start with his image because it's super cool. You ready? Alex, are you there? Let's see if I can find you. Alex, let's see. Oh, let me take off this first thing, Alex. Hang on. All right, Alex, you there?
Hey. Thanks for having me back, Aurora. And hello to everybody out there. Tonight, we're going to go look at one of my favorite galaxies, NGC 4565. It's one of my favorites because it's so long and skinny. Look at that. It's like a needle, and that's what it's called, the Needle Galaxy.
Cool. Well, tell us more.
It's easy enough to find. First off, you find the Big Dipper looking off to the east. See the east here? And you look at the Big Dipper.
Yeah.
And you arc to Arcturus, and it's right up in here. As you zoom in a little bit, you can see more and more detail, and smaller stars will come into view. And finally, you might get a little picture of the galaxy itself.
Oh, wow.
This is what you might see if you got it in a great big telescope with a really good eyepiece on a dark night. But in order to really pick up the detail on it, you might want to get a camera, and then you could see it in color. This is the result of about 20 pictures in each of 4 filters, all put together. I've brought in a picture for you here from the ultraviolet space telescope called GALEX. And I've added some visible light telescopes from Hubble so that you can see better detail and different detail than you can see in the visible light picture here.
Oh, cool.
NGC 4565 was first found by William Herschel back in the 1700s. It was the brightest of the Coma 1 galaxy group, a group of about 10,000 galaxies up in Coma Berenices. It's 10th magnitude, which makes it pretty bright for a galaxy, but not so bright that you can see it with your naked eye. The light that's coming to you has been coming here for 43 million years.
Wow.
And it's about 140,000 light years from one end to the other of the needle. I've read that there are a trillion stars up there, but I find that a little bit hard to believe since that's so much more than our own Milky Way has, and we're about the same size. Just like all spiral galaxies, this has a nice dust lane hiding some of the stars and a central bulge where a lot of the stars are in the middle. One other thing it has is about 240 of these things. Now, this is from the Milky Way. It's M13. It's called a globular cluster. There are maybe 500,000 to 1 million stars, very old stars, all orbiting around each other here, and they in turn are orbiting around the central part of the galaxy here. And that's all very interesting. There's about 150 of them in the Milky Way. One other thing you'll notice in ultraviolet in particular, see this satellite galaxy here?
Yeah.
It's actually had the gravity. It's probably passed through this area and pulled part of the galaxy up a little bit, and so it's got a little tweak at the end of the needle.
Huh. Wow.
Now, depending on where you're standing in a spiral, an edge-on galaxy, you're going to get a different view. If you're standing here on this and you're looking in towards the center of the Milky Way here, you can see that you're going to get a view about like this. And this is an artist's view of what the Milky Way would look like. Different view. Here's one from up above, artist's rendering of Milky Way. Here's one from edge on. Here's another one from edge on. Here's one from what's called a face-on galaxy, and this one's tilted just slightly different towards us so that we see it kind of at an angle. So what we see depends a lot on what the shape of the galaxy is and which way it's turned to us.
Yeah.
But there are also some galaxies that doesn't matter which way they're turned. They're big blobs. They're elliptical galaxies, they're called, and they're big and round. Here's 84 and 86, or 86 and 84, I forget which is which, and a whole lot of other galaxies. This is a galaxy cluster in the Virgo galaxy cluster. Look how many of them there are in this picture. 1, 2, 3, 4, 5.
Wow.
Little ones, big ones, all of them.
Mm-hmm.
And they all fit into a classification. Hubble tried to classify them according to whether they were just big balls of gas and stars, or they had spirals of some kind or another with bars or without bars. And then he finally has some that are just irregular. They're just weird. They've got weird, odd shapes. Well, that's my view of the NGC 4565. It's so cool because it's so long and skinny. I hope you enjoyed visiting with us, and I hope to come back again and tell you more about some other wonders of the sky.
Yes, absolutely. Thank you so much. Yay! He's amazing. So yeah, you can give him kudos in the comments. Let him know if you enjoyed seeing his images that he took. So thank you, Alex. All right, so Brian, I was going to introduce you to Brian. He is also an astronomer. He took the images you're going to see behind him here in just a second, and he's going to tell you about an announcement we have for Central Coast Astronomy. Are you ready, Brian? Let's see if I can find you.
I'm ready.
All right, there you are.
Yes, where am I? There I
Yes.
am. Yeah, Aurora. Hi, everybody. I am Brian Cox with Central Coast Astronomical, and I'm pleased to introduce our brand new Central Coast Astronomical Club store. Now, in this store, we have all kinds of different items that you can buy. So you can have your very own, for instance, Central Coast Astronomical coffee cup. And don't worry, we have one bigger than this. For me, that's too small for a cup of coffee. I need at least twice that size. But we have more. We have various different shirts. Now, what's neat is not only do many of the items have our club logo, but I would say maybe more importantly, or at least as important, they also have astrophoto images. each different item has a different image for a certain deep sky object right now. We're getting some local objects too that would be from our solar system. But every image was taken by Central Coast Astronomical Club members. And I happen to know the one who took this photo. This is M42. I took that one. But we also have many from Lee Coombs, who's doing a moon show, by the way, coming up on June 15th. More on that later.
Oh, wow.
But please go take a look at this store. All you have to do to get to it, one, you can follow the link that I put right in the chat right now, or you can go to our main website, which I'll bring up right here. That, by the way, would be the same as our email address. So that's centralcoastastronomy.org. And then you'll see a little link up on the top right-hand corner that says Club Store. So we'll probably talk about that a little bit more in the end. If we have time, I'll give you a little short tour. But be sure to take a look. And if you see, if there's different kind of item you'd like to see in the store with an astronomy object picture on it, let's say, hit us up at questions@centralcoastastronomy.org, and we'll see what we can do to set that up for you.
Awesome. Thank you so much. I know I have to order mine, so I know I'm going to be ordering lots of things. So yes. And it's so cool because our astronomers, though, it's their images on there, and you get to support us as a club, and you get merchandise, which is really cool. All right. Should we go ahead and get started with tonight's presentation? Yes. Okay. Real quick. I've already had some questions about the Stargazing app. One of the things, or Stargazer's Almanac. So this is available from Sky and Telescope. You can pick your latitude. They have a few different latitudes available for northern and southern hemisphere. And then it's a quick one shot of what's happening with the planets and the meteor showers and all that stuff for the evening. So you can get this. Usually they're like $5. And the other question I had was the star chart. So these are available for free. You download them from skymaps.com.org. One of those. Skymaps.org, I think. Excuse me. And you get it for the night sky, and it has the information about what's the best stuff to look at tonight. If you have this out, get a highlighter, and as we talk about different constellations, kind of make a note where we are and where those things are. So it's a really good visual you can have. The way you use this is you stick it over your head, and what you see here is projected on the night sky. It's kind of how you use it. So it's super, there's a lot of information on here. So if this is confusing, don't worry about it. Don't bother with it. In fact, we're going to take you on that tour tonight. So we're going to have a lot of fun. All right, you guys ready? Okay, I'm going to make this little box disappear. You guys ready? Go ahead and take your last little screenshot of it. Go ahead and make a note if you'd like. Ready? 3, 2, 1. All right, Kent, we need to introduce you.
Okay,
Hi,
I'm here.
Excellent. So Kent is our astronomer for this evening. He is going to take us on a tour of the night sky. And Kent, you started with a little telescope. Is that right?
Yeah, actually, a little telescope originally was a 60 millimeter, but the photo there shows my 8-inch.
Oh, it does.
Which is an old orange Celestron Schmidt-Cassegrain.
Mm-hmm. Yes.
And then in the corner, when I went to Western Australia for my first trip, that's at Mr. Fuji's observatory.
Mm-hmm.
He's the gentleman standing there between me and Morris Clark. So,
right
there's Mr. Fuji. He named the observatory Kuro Observatory after his beloved dog that had passed away.
Aww.
And you can see a dome in the distance, and he had another dome. There's actually 2 domes. This is in the wheat belt of Western Australia. You can see how flat the area is.
Good for stargazing, huh?
Oh yeah. I mean, it's really, really nice.
Yeah.
Some of the darkest skies that I've ever seen.
Now you also have
Australia.
you also have a book. I didn't know that you had written and authored a book, 2 books, right?
Oh yeah, 2 books. There was one in 1997. Called Planetary Pages, and it was like 303 planetary nebula that I observed with the old 8-inch scope there. And then in 2017, I got a 20-inch scope around 1995, so I could go a lot deeper. There it is.
Mm-hmm.
And the first image up at the top to the left, that's actually the breakdown structure that I took or actually air freighted to Western Australia. The middle picture at the bottom is the scope I've had since '95. and that one's a star splitter, and basically you can see the difference in color between the two of them. And in fact, you can see the all the way to the right. That's the 20-inch mirror in a specially made shipping crate to protect it. You know, when you send stuff air freight, you never know what's going to happen to them.
Yes.
And so that's actually a special crate. The guys that made it actually make crates for instruments that go to nuclear power plants.
Oh, wow.
I can't remember the name of they're really a great group. I was able to ship everything, had no problems,
Yeah.
and the cases were built really tough.
Yeah, so it was good to put a mirror in.
Oh yeah, that's it. I didn't want to just throw it in a piece of luggage and have it bounce around.
That would not be good.
You never know how stuff is handled on,
no.
like domestic or not domestic, but international luggage handlers.
Yeah,
and,
absolutely.
Anything that break, I'd be totally out of luck.
That's true.
And so it was really important, and it worked great. I shipped that mirror back and forth 3 different times.
Wow, to Australia.
And everything worked out.
Yeah.
The important thing is to have a good agent. I had an agent in LA at LAX area, and a good agent in Perth, Australia, to make sure all your equipment is handled properly, gets through customs and all that sort of stuff.
Yeah. So speaking of taking people on trips, are you ready to take everyone on a tour of the night sky for tonight?
Sure.
All right. Now,
let's go.
All right, let's do it. For those of you who are brand new, welcome. We are the Central Coast Astronomical Society, and we are doing stargazing for this month of May. And just so you know, we're going to be working through this handout. So the first object we're going to be looking at, you can actually see, is called the hunting dogs. Is that right, Kent?
Oh, do you want to handle Mercury first?
I could. Yes, absolutely. In fact, let me just have you run the show. I'm just going to be along for the ride. Let's talk about the moon and the planet that is up. So go ahead.
Yeah, the moon is actually, we're the 15th, so we're heading towards the first quarter will be on the 18th or 19th. So we're kind of halfway in between. I went out last night and looked. Should be a nice crescent moon, unless you've got the weather we have here where you can't see anything right now.
Yes, that's very true.
But Mercury right now is going through a really nice peak. I looked in Astronomy magazine, and it reaches a peak of like 22 degrees above the western horizon. Yeah, you can see that orange loop there, and it's in the darkness. And so on it's the 17th, reached maximum elongation out there. And so it's actually into the dark part of the sky. So if you have a good western horizon, a pair of binoculars, you shouldn't have any trouble pulling it in. I think it's, 0.9 for the magnitude. I'm trying to remember that from both Sky and Telescope and Astronomy magazine will tell you about that sort of thing. And then on the 28th of the month, this is an extra, Venus is coming up. And so Venus and Mercury are right next to each other in the west on the 28th. And that's that blue line where the orange line, the orange loop, and the blue line intersect. That's when Venus and Mercury are right next to each other. Venus will be brighter, so you have a bright star and then a dimmer star next to it. Main thing is have a good western horizon. Someplace, doesn't have to be too horribly dark. It just has to be a good view.
Yes. All right.
And so I think that covers the solar system.
I think that covers it. Now let's go to deep sky. You guys ready for deep sky? I forgot to ask our viewers out there, if you could drop us a note of where you are in the world tonight so we can take a look at that, astronomically speaking, and kind of point out a few things that are in your area. That would be really helpful to us. And Kent, let's go ahead and start with our very first constellation.
Constellation, the hunting dogs. Canes Venatici. I'm probably
Okay.
butchering that, but it really is not much of a constellation. It's two stars with a line drawn in there. It's a modern constellation. It was created by the Polish astronomer Johannes Helvetius in 1687,
Hmm.
and it's often depicted as two dogs. The northern dog is called Asteron, meaning starry, and the southern dog is called Shara, meaning joy. And Shara, that dog contains the two stars you can see, the Alpha and Betas
Hmm.
of this constellation. And they're actually two fairly easy naked eye stars. And that's like the bulk of what you can see. If being a modern constellation, these guys tried to fill in little spots.
Yeah.
And, it doesn't really look like anything,
Mm-mm.
but it's pretty easy to see.
So how would we
And
find these two stars? Because I mean, when
the
we go out,
easiest,
yeah, we go outside, we don't see these little connectors and
yeah, the best
labels.
thing, almost everyone knows where the Big Dipper is. So
Okay.
that's a real good indicator. You got the handle of the Big Dipper,
Hmm.
and you just go over, actually, in this case, for the way it's oriented, you go eastward, and the next bright star, you see there's the bright one, and then there's a slightly fainter one up there, and that's the beta. You got the alpha and the beta, and that's what I do is I just find the Big Dipper and then look over from it.
Okay, great.
And you can see it's kind of inside the curve of the handle there.
Yeah.
And so, if you go the other way, you're going the wrong direction.
Okay,
And
great.
so that's one way to go. And the alpha star there is actually got a weird name. It's Coriolis. It's the heart of Charles, which was Charles the First of King of England. Uh, it's also called Alpha Canum Venticorium, I guess is the
Oh,
way
wow.
to describe it. It's a nice double star. Consists of a brighter component, which is 2.9 visual magnitude, uh, with a fainter component that's 5.5 visual magnitude, and they're separated by 19.2 arc seconds. So that's a nice separation. So alpha is even for small scopes, it's a nice double star. It was discovered by Christian Mayer sometime between 1776 and 1777, and he was using a 2.5-inch refractor. So he was using a fairly small scope.
Oh, wow.
The brighter stars is about 123 light years away, where the fainter star is 107 light years distant. So you can see they're not a binary; they're
Mm-mm.
basically line of sight
Yeah.
on something like that. In my 8-inch scope, I see it as a pair of white stars,
Oh,
and
wow.
so it's just a nice double, and you can see it with your naked eye. That's a nice thing.
Yeah.
You look right up, and there it is, and then it's easy to put it in your finder scope and get it in your eyepiece.
Yeah, no, let
And
me ask you because I know you're going to use this term a lot tonight. One of the questions coming in already is when you say modern, what makes it modern? Modern constellation.
okay, way back, there's like 48 what they call the Greek classical
Hmm.
constellations.
Okay.
And basically, they're in Ptolemy's catalog. And those have pretty much stayed. There's been some modifications, but uh, they did such a good job. We've still got most all of the 48. They broke up one, which was Argo, the ship for the
Hmm.
Jason and the Argonauts. They broke that into three, but for the most part, they've stuck. And what's happened is, the guys went down to the southern hemisphere and saw all this stuff that wasn't in wasn't in the catalog, and they realized that these were stars the Greeks never saw. So they created a bunch of modern constellations.
Now, was
And
it
so
80?
anything past,
Oh, I'm
pardon,
sorry. Was it 88 or 48 constellations?
there's 88 total now, but the Greeks, I think it was 48 that the Greeks had because they didn't have the southern hemisphere
Oh,
underneath their
okay.
belt.
Okay.
So there was all those. And then there's some Johnny-come-latelys that created extra constellations,
Mm-hmm.
like old Johannes here
Mm-hmm.
in 1687 cranked one out. So, you
Okay.
know, there's actually been a whole variety of weird constellations that have been created by different groups over time. And in,
Yes.
I think it was 1930, the
Mm-hmm.
uh, the astronomical, International Astronomical Group got together, and they decided to set it all in concrete. And so that's where we get our 88 constellations.
Awesome. Well,
Some
thank
got
you.
chucked out,
Yeah.
some made it, you know.
Yeah. Okay,
And
great.
so
Thanks. Well,
that's the history.
that's perfect. That's exactly what I was looking for. Okay, great. Do you want to move on to
Well,
M51?
let's go to the pretty object
Yeah, let's do that
in
one.
Canes Venatici. That's Messier 51,
Okay.
which is a face-on spiral galaxy. Plus, there's a smaller interacting galaxy on there. And the larger and brighter face-on galaxy is given an NGC number of 5194. And it's also given the nickname the Whirlpool galaxy.
Mm-hmm.
You can see the spiral pattern there.
Yeah.
And you can also see the little interacting galaxy there. It's kind of distorted some of the arms
Mm-hmm.
in the larger galaxy.
Yeah.
And
How do we
the
find this one?
okay, there's an interesting way to find it. You start at the end star in the handle of the Big Dipper,
Okay.
right there, and you kind of have to blow up the field, and there's like a below it, kind of heading towards Alpha uh, Canes Venatici there,
Okay.
kind of head in that direction, and there's like a little triangle of stars, and at the base of the little triangle of stars, there's a fuzzy object, and I can see this in my 750 binoculars.
Oh, wow.
And there's M51. You can see the spiral pattern, and then for some reason the graphics on this star charting thing, it has like a monster supernova going on. that there's
It's not real.
a bright. Yeah, it's not real. It's something. If it was real, there'd be something really bad going on with that smaller galaxy. I mean, it's some artifact, I believe, in the graphics
Okay.
of this program.
Okay, good to
And
know.
they probably just don't realize that it occurs.
Well, okay, so let's
But
do it again. Let's so we've got the Big Dipper here. Here, I'll connect the dots.
Yeah, we
just
got
so
Big Dipper. We
Big
got the
Dipper.
handle of the Big Dipper, which
handle.
everyone knows. Then
Mhm.
you kind of go down a bit, or actually in this case it'd be up
Uh-huh.
and over a little bit. And there's that funny little triangle there.
Okay.
And there's
And
the
it's right
galaxy at the base
there.
of the
I see
triangle.
it.
And many a time sitting out in Navajo Flats with my binoculars, I could flip it up there, kind of slide down, see that triangle, and then boom, there's this. It just looks like a little fuzzy blob. You can't, it's not a star when you see it in binoculars.
Nice.
It has some physical size to it.
Okay,
And
great.
so that's the easy way to find it.
Okay.
I've got a few more facts here.
Sure.
The nickname, the Whirlpool Galaxy, is most likely due to the drawings of Lord Rose in the mid 1800s. He built a telescope in Ireland that had a diameter of 6 feet and was made out of metal. I think they call it speculum or something like that for the metal. And he had enough light gathering ability so he could see. He made drawings of the spiral arms there. And it does look kind of like a whirlpool. He didn't give it that nickname, and I haven't been able to find where it came from, but I think it's due to some of his drawings.
Mhm.
The actual discovery of the whirlpool there was done by Charles Messier on October 13th, 1775. The smaller galaxy, the interacting one there, is NGC 5195. It's got a visual magnitude of 9.5, was discovered by Pierre Machine on March 21st, 1781. And in his third catalog of 1784, Messier notes M51 as a double nebula, thus combining his observations and Machine's observations. And Merchain sent a lot of observations to Messier over. They kind of worked together on there. And so M51 is actually a pair of galaxies.
Mm-hmm.
Oh, another thing is a pair is 27 million light years away. Let's see, I guess I didn't give a visual magnitude for the Whirlpool part. That's magnitude 8.4. But I can see it in 750 binoculars. And, once you see where it is, then you put your finder scope on it, look through your eyepiece, and it should pop up as long as you've got your eyepiece aligned with your finder scope.
Yes, that's important.
You wouldn't believe how many people can't find anything because of that.
Oh my goodness.
That's like the first lesson is when you're out with your telescope,
Yeah.
pick something in the distance, line up your finder scope and making sure that when you look through your finder scope at something in the center, you also see it in your
You can see an eyepiece. Yeah, that's important.
Otherwise, there's usually some screws where you can adjust your finder scope.
Yeah.
So that the crosshairs land on the object and you see it in your eyepiece. Then you're good for the night.
Yep, that's true. That's true. Now, there's another one around here that you liked.
There's a really beautiful one, Messier 3.
Let's do that one.
And Messier 3 is kind of interesting to find. It's a globular cluster, has a visual magnitude of 5.9. So there's people with good vision can probably pull it in. It's about 190 light years across, has half a million stars in it, or 500,000. So yeah, 500,000. A lot of stars. It's about 34,000 light years distance. Charles Messier discovered this beautiful object on May 3rd, 1764. And you can see in 750 binoculars, it forms a skinny triangle with two other faint stars. Okay. And how you find it is, remember that Corcori or Alpha Canes Venatici star? You go to that, then you go down to Arcturus, which is in Boötes, excuse me. And if you can see how it's roughly halfway in between. It's a little bit closer to Arcturus than it is Corcori there.
Yeah.
But if you blow it up a bit around the globular cluster, you might be able to see. When I see it through my binoculars, I see that little pair of stars. There's one, or let's see, there's the globular, there's one, and then down further you can see the third star. It forms like a skinny triangle. Not that one, keep going.
Oh, this one?
That one, yeah. So basically when it's, it doesn't even have to be that dark out initially when you still got twilight. I look for my binoculars and I find that skinny triangle, and I notice the one to the upper left is fuzzy. It's fat.
Yeah.
Compared to the other two stars, and then you've got it. Then you can swing your finder scope around on it, and it's a really impressive one because it's the first really nice globular cluster up in the spring.
Yeah.
When we were doing star parties, that was like the first really wow object to put in the 20-inch.
Nice. Well, before we go on to the booties, let's go. I always say booties, like baby booties, but
yeah,
I know some people.
I don't know how. I pronounce it Boötes, but I'm probably butchering it also.
All right, let's see if we can find those two objects just real quick. So let's go out for a walk, everyone. It's now your turn. So we're gonna go out for a walk. You tell me when you see the Big Dipper. Do you see a Big Dipper? Here, if I zoom out a little bit more, you'll see it. Do you see the Big Dipper? Okay, put your finger on it. Now, where is M51? If I zoom into Big Dipper, do you see M51? Or where would you start to look? Yeah, you go to the Big Dipper, which is here, and you see the arc, and then you start to look in this area, right? So we'll zoom in a little bit more. Do you see that triangle that he was talking about? We drop down from the handle, you see the triangle, and then there's your object right there, right? I can't get stellarium on it. There we go. It's right there. Cool. All right. Now, where is M3? So we're still on the Big Dipper. We're going to arc to Arcturus. You see how we can just kind of follow that arc? Okay, there's the really bright star Kent was talking about before. And this is, we're going to go to this constellation more in just a minute. Okay, so keep that one in mind. And then do you remember how he also said from the end of the handle, you kind of go down from the handle, and this is the hunting dogs we were just talking about? And then he said it was halfway between these two stars. So we're going to go about halfway in between. Take your best guess. I'm going to zoom in. You tell me when you think you see it. Okay, so we're looking for that triangle. We're going halfway between. Do you see the triangle yet? I know you see it, Kent, don't you?
I think I see it. Yeah.
There it is. Right on target. And that's the one that doesn't quite look like a star. Okay, great. Perfect. Let's go ahead and go to the constellation here with Arcturus.
Okay, that's Boötes.
Okay.
I think.
Yes.
It's the herdsman. It's an ancient Greek constellation. So it was, with the Greeks a long time ago. And the brightest star, Arcturus, is also known as the Bear Watcher. So it's, I guess, watching the Big Dipper is the Big Bear.
Mm-hmm.
And it's also called Alpha Boötes. This is actually the fourth brightest star in the sky. And it's also the brightest star in the northern celestial hemisphere. You've got the northern hemisphere, you got the southern celestial hemisphere.
Mm-hmm.
And this is actually the brightest one in there. It's got a visual magnitude of 0.04. So it's
bright.
almost an outright zero magnitude star.
Yeah.
It's a red or an orange giant, about 215 times brighter and 25 times the diameter of our sun. And it's nearby. It's 37 light years away. And I kind of gave you bad information about the World's Fair there.
Oh,
When we
no.
were talking about it. It turns out I had the wrong World's Fair. They didn't have
Oh.
photoelectric cells in 1893. It turns out 40 years later, in 1933, they had another big World's Fair in Chicago.
Mm-hmm.
It's a 1933 one. And from Yerkes Observatory, which I don't think is that far from Chicago, they used the light of Arcturus to trigger a photocell, and that lit up like the big spotlights and all the stuff at night.
Wow.
There at the 1933 World's Fair in Chicago. So that's a little aside.
That's cool. We were talking about that before.
Yeah. I did some. I wanted to double check, and when I
Sure.
did, I go, yeah, because they had a really big fair back in 1893. It was like the very first really big one in the United States.
Yeah.
And countries from all over the world sent their own display things.
Yes.
So,
now, there's only one thing to really look at in this constellation, right?
Yeah, well, there's a bunch of little galaxies there. I just picked something that was interesting.
Okay. So tell us
and
about it.
It was also kind of findable, and that's NGC 5466.
Okay.
It's a globular cluster. It's not as bright but it's not anywhere close to M3, but it's about 5 degrees east of M3. So you find M3, you just peruse eastward, and you should get to it. And it's got a visual magnitude of 9.0, so it's not really bright, but not super faint.
Mm-hmm.
It's got a diameter about 9 arc minutes, and it's way out there. It's 51,500 light years, so
Wow.
it's out there a ways. It was discovered by William Herschel on May 17, 1784, and on deep exposures, they found there's a trail of stars leading behind this sky. And they think what it really might be is not a globular cluster, but a core of a dwarf galaxy that's been kind of cannibalized by the tidal forces of the Milky Way and been losing stars. So it's not a very rich globular cluster. And it might actually not be a globular cluster, but might be a dwarf galaxy core. Of course, the time spans for disassembling a dwarf galaxy are very, very, on the order of billions of years.
Yeah.
But, they did pick up this trail of stars that lead behind it. And so that's an interesting thing about NGC 5466.
Uh-huh. Oh, I was just going to say, to give our viewers kind of an idea where it is, we have this one, and the NGC 5466 is here. And
Right.
here's Arcturus, and then way up here, this is the triangle where we saw M3. So to kind of give you an idea of how these things are laid out.
Yeah, so you can see that basically it's about 5 degrees east
Yeah.
going from there to there. You know, if I was star hopping, I'd find that other triangle between it and M3, and you know, with my binoculars.
Mm-hmm.
And then there's like a pair of stars kind of a little bit lower and to the left. I'd probably go from there, and then I'd hop over to the star right under
This one.
5466. Yeah,
Yeah.
you know, using the star chart. So once you do it with binoculars, then you got a pretty good idea what to follow with your finder scope.
Ah, got
And
it.
so that's pretty well how they call the technique star hopping,
Right.
where you actually have something you recognize and you hop along from various patterns to get to your deep sky object. And you might not even be able, most cases, you won't be able to see it through your binoculars, but you know it's in a bright area. So
Yeah.
that's when you put your finder scope in this rough area and do a search pattern through
Mm-hmm.
your eyepiece.
Yes. Now we
And
have. I'm sorry. Go ahead.
Oh, I'm just saying, and that's it for NGC 5466.
That's what I was going to say. Okay, perfect. Now somebody's hair is up in the sky. Is that right?
Yeah, this is the next constellation. This is again a modern constellation. It's called Coma Berenices, or the Hair of Berenice. It's a modern constellation created by Caspar Whirlpool in 1536. And it was originally shown as a tuft at the end of the tail of Leo, but they kind of stole that from Leo.
They cut
Leo
off his
now
tail.
ends at poor Leo. Yeah, it ends at that one bright star at the end, which is Debnola, tail of the lion.
Yeah.
But at one time it had this tuft there, and Bernice, actually, it's Bernice the second, was the wife of Ptolemy the third, which was an Egyptian pharaoh. And just to give you some reference,
Mm-hmm.
Cleopatra was actually Ptolemy the 13th. So we're talking 10 generations. So Bernice actually was a real person that lived in around the 3rd century BC with her king, the husband, Ptolemy the third.
Mm-hmm.
And the story goes that she promised Aphrodite that if her husband was safe in battle and came home victorious,
Uh-huh.
she would cut off her hair and put it in the temple as a sacrifice or a goodwill thing, saying thank you, my husband got home safe.
Oh,
And she
wow.
did that. And the problem was, at a big party, the hair disappeared. And they were really angry at the guards at the temple, who were supposed to make sure something like that didn't run off. And luckily, a Greek guy stepped in, a Greek astronomer, and he said Aphrodite liked the sacrifice so well, she put your hair in the sky. And he pointed at
Oh.
roughly the Coma Berenice area. And, that made them happy. They weren't going to kill the guards after that point. But that's some of the mythology behind
Nice.
the constellation itself.
All right, let's see if we can find this constellation. So here we go. It's the stars are faint.
Yeah, there are actually no bright stars there. You can kind of see how you can hop from, like, if you start at the end of the Big Dipper
Mm-hmm.
and hop to Alpha Canes Venatici,
Mm-hmm.
and you continue on to the end of the tail of Leo. Actually, I can see Leo on the screen. There it is.
Yeah.
That's Debnola, which means tail of the lion. You can see it's kind of between Debnola and Alpha Canes Venatici. There's actually an open cluster there.
Yes.
And that's our next object. It's really unusual. It's actually called Melotte 111 because Melotte made a list of open clusters, and he put this object there. It's naked eye. In fact, Ptolemy actually cataloged it sometime between 127 and 151 AD. You could look up there and see a fuzzy spot, and that was this extended grouping of stars. And it didn't get a Messier number. It didn't get an NGC number. It had to wait for Melotte to go out there and catalog it.
Wow.
But it was under Ptolemy's list. And the weird thing is, I was doing some research this afternoon. Almost nobody brings up that it's in Ptolemy's catalog, which is kind of strange.
Yeah, that is strange.
And so that's the first catalog, and it's actually Ptolemy, which goes way back.
Huh.
And so, it's actually best seen in a pair of binoculars.
Because it's so big, right? It's such a big object.
It's so big, and it really is a scattered open cluster. In fact, it's right at the edge of actually coming apart. As open clusters are in the disk of the galaxy, and as they go around through the disk, there's tidal forces, and they tend to lose stars, and eventually they get broken apart so bad you can't tell who came from what.
Yeah.
And you don't have a cluster there. And this one is getting close. It's right at the edge of not having enough mass to hold it together as a cluster.
Yeah.
But it's a naked eye object. It's really pretty to look at in binoculars. And so
nice.
That's the story. They also call it the Coma cluster of stars, which is another name. Actually, an easier name than Melotte 111 there.
Yes, I think you're right. Now, there's another one. There's two more objects we were going to look at here.
Actually, that open cluster, the Coma cluster is useful. You can use a few stars to get right into the area of an edge-on galaxy. Alex was talking about it.
Yes.
And he had that nice photo. Unfortunately, I couldn't get the audio from Alex, so all I saw was a little red cursor moving around, and I could hear you making sounds in the background, but I couldn't hear anything coming through from Alex, which was unfortunate.
I'm sorry.
But no, that's okay. But there it is. There's what they call the needle. It's a beautiful edge-on galaxy. Has a visual magnitude. I've got 9.6, distance 32 million light years. Alex had extra information on it. Depending on the source, they'll vary. But he had the diameter as 140,000 light years, so it's really stretched out there.
Yeah.
But with the way you've got it now, you can see how you can use the cluster. Remember how we talked about the pairs of stars? You've got that little pair right there that the cursor is near. If you draw a line through it, it almost intersects, and you've got the other faint pair intersect. So you got two intersections. So if you're looking with your binoculars, you can kind of imagine a line like that going through the two sets.
Yes.
And where they intersect is roughly where the needle is. And when I look through my finder scope, I don't see anything, but I can see the parts of the cluster there. So I slide it over to where the two lines intersect and just start looking through my eyepiece. And I'll do like a little spiral search pattern. And usually it's right on.
Yeah.
And in my 20-inch, it looks totally awesome. You have a hard time getting people off the ladder to let the next person on, because it's just really a beautiful, almost totally edge-on galaxy.
Nice.
And so that takes care of, or at least that's one way of getting to NGC 4565.
Okay, great.
And we've got one more object left in Coma Berenices.
This one had a funny name. This one had a funny name.
Yeah, it's called the Black-Eyed Galaxy, or M64. And it's kind of a toughie. You need a chart. You got to be patient to get down to it. Use your binoculars with a chart, and you get down to it. And it's an unusual galaxy. Basically, it's got a large dust cloud. You can see it there, that dark area above the core.
Yeah.
For some reason, usually if you're going to see a dust lane, it's some distance away from the core. And this is like a big cloud of dust. I don't know, maybe a black hole chewed up a bunch of stars or something. But, there is a really good-sized dust cloud there. M64 itself has a visual magnitude of 8.5, is roughly about 56,000 light years across, and is at a distance of 18.3 million light years. It was discovered by Edward Pigott on March 23rd, 1799. And in my 8-inch scope, I could see the dust cloud or the black eye
Oh, wow.
without too much work. As long, the other thing is this constellation gets pretty high up in the sky. And so that means less air you have to look through.
Yes.
And so, yeah, the black eye, and the reason I picked it was there's a ton of galaxies throughout the Coma Berenices, Virgo area.
Yes.
There's just a whole ton of galaxies in that general area. And it's just, this was a real unusual one. So, and it's a Messier object. So I thought it was kind of a neat one to cover.
That's wonderful. That's great. Okay, let me just pause you for a minute because I think that does it for that one, and we only have one left. Is that right?
Yeah, we just got Virgo left.
Virgo left.
believe.
Okay, so let's do a quick recap. So we're gonna erase all these very handy dandy labels, and you and I, audience, are you guys ready to go outside? Here, we're gonna go outside for a walk, and we're gonna look up. Kent is not here anymore to show us where anything is. So we're going to go outside and we're going to look we're going to find the Big Dipper. So tell me if you see it. Here, if I zoom out enough, you'll be able to see it. Okay, we're kind of looking kind of east-ish, north-ish, northeast-ish. There we go. Do you see the Big Dipper? Do you see it? Okay, there we go. We've got the Big Dipper. Okay, can you find Arcturus? Can you find that really bright star in Boötes? Yeah, you can do the arc to Arcturus in here. Okay, great. And then can you find the 2 hunting dogs? Okay, so we're gonna kind of come to the end of this handle from the Big Dipper. And then where are the 2 hunting dogs? That's right, we're gonna come straight off here. We've got 2 hunting dogs. And if you remember something Kent had said, he had said if you go to the tail of Leo the lion, so basically you're gonna go from the end of the handle through the brighter of the 2 hunting dogs, and you're just going to keep on going to the tail of Leo the lion. And if you go in between the dogs and the lion, you're going to find that open cluster that he was just talking about. Do you see it here? And right below that open cluster, you're going to find that first other object we were talking about. What was the number of it? Not the open cluster, but NGC, the needle.
Oh, yeah, 4565.
4565 is going to be right underneath. So you can look at this tonight with your binoculars. And then if you drop down right below it, you'll be able to see the needle. Can you see? Well, I know, Kent, you can see it. But so if you connect these 2 bright stars here, that's one line you're going to look at. And if you're going to connect these 2 stars here, there's another line. And it's actually right there. I don't know if I can get stellarium on it, but do you see it right there? And there is the needle. And then Kent had mentioned that other object, which you will need star charts to find, but he has, it was right around this area, wasn't it, Kent?
Yeah, I believe.
It's right around
that
this
there,
area.
I think, yeah, the black eye.
There it is. It's right here. It's a faint object, so you're going to need some more help. You won't be able to pop it up like you can in stellarium, but it was right near this lower star here. If I back out, you can see where the open cluster is and the needle. And this was much, much further down. Okay, I think we're ready. We are ready for our last constellation. You guys ready? All right. So where are we going next?
We're headed to Virgo, the Virgin.
Let's go to Virgo.
It's another ancient Greek zodiacal constellation. So there's 12 zodiacal constellations. Those are the constellations that the sun and the planets go through. Part of what they call the zodiac. And so, it's been around for a long time. And the brightest star is actually, in that picture, she's holding a sheaf of grain. And in that sheaf of grain is Spicia, which is the brightest star in Virgo. It's Alpha Virginis. It's got a visual magnitude of 0.98, so it's almost a magnitude 1.0 star. It's the 16th brightest star in the sky. And Spica itself, and I'm probably butchering that, but
Oh, Spica.
anyhow,
Yeah.
Spica, Spica, yeah,
Uh-huh.
it means ear of grain. So it's, apropos that she's holding a sheath or an ear of grain,
Mm-hmm.
and they've got Spica right there,
Uh-huh.
centered on it.
Yes.
Um, it's kind of an interesting star. It's about 262 light years away, and it's a very close binary made up of two heavy stars, B type stars, which orbit each other only in 4 days. So that's really a short orbital period. The brighter component is 1,300 times brighter. It's 9 times more massive and 8 times the diameter of our sun. The fainter component is 1,300 times brighter, 4.5 times as massive, and 4 times the diameter of our sun. And these two components are only 11.3 million miles apart.
Wow.
For example, from our Earth to our sun is 93 million. So you've got two really massive, really bright stars, whipping around each other every 4
Mm-hmm.
days. So that's you can't see the double
Mm-hmm.
because it's spectroscopic binary. It's too close, but with a spectroscope, they see the lines shift back and forth.
Mm-hmm.
So that's how they figure it out.
Oh,
And
okay.
so that's an interesting star. That's the Alpha star in Virgo. You want to go on to the next object?
Yes. Let's go ahead and let's do all of them. So
Okay,
there's 3 right in a
we'll
row.
start. We'll start with M84,
Okay.
which is an elliptical galaxy. It's got a visual magnitude of 9.1, a diameter of 110,000 light years.
Mm-hmm.
It's 58 million light years away from us. It was discovered by Charles Messier on March 18th, 1781, and it's the westernmost galaxy in Markarian's chain of galaxies. And there you can see that kind of chain, the loop of galaxies there. And in fact, one part of that, the tail end of it, is actually in Coma Berenices.
Oh.
There's like the boundary line between Virgo
Mm-hmm.
and Coma Berenices is very close here. But this is the center of what they call the Virgo supercluster of galaxies. And you see M84 there,
Mm-hmm.
and you see the other bright object just to the left of it. That's M86. It's another elliptical galaxy. It's got a visual magnitude of 8.9, a diameter of about 147,000 light years across. It's 57 million light years from us. It was discovered by Charles Messier the same night, March 18, 1781, and it's about 17 arc minutes east of M84. It's also the brightest galaxy in Markarian's chain of galaxies there.
Nice.
And
So
that's really
yeah,
kind of neat.
that is really
Uh,
cool. Now
with
M87, this is also in the same picture, isn't it?
well, you have to shrink those guys down a little bit more, and then there it is. It popped
There
out
it
at
is.
the bottom. This other one, yeah, M87. I'll talk about that. It's a massive elliptical galaxy. Has a visual magnitude of 8.6. It's got a diameter of 132,000 light years, and it's about 55 million light years from us. So M84, M86, and M87 pretty much are all roughly the same distance. And it makes sense because they're all part of this Virgo supercluster of galaxies. Uh, it also is called Virgo A because it's the strongest source of radio emissions, uh, in the constellation of Virgo. And the reason for that is it's got a massive black hole in the center, and it's also got a relativistic jet blasting out from the black hole. It was the actual jet was discovered by Herbert Curtis in 1918, and they recently took a picture of that black hole using telescopes from all over the world, and there's a nice write-up, nice
Yes.
article in the club monthly newsletter
Mm-hmm.
that has quite a bit of the detailed information on the effort. to actually take a picture of a black hole.
Yeah.
It's neat. The weird thing about M87, it's also estimated to have 16,000 globular clusters around
Whoa, 16,000? Are you sure?
it. 16,000. That's the information I came across.
How many do we have in our Milky Way? Is it
We
estimated?
got like between 150 and 200 that we've seen. They estimate the Milky Way has about 400 or so. There's parts we can't see, and
400 is very different from 16,000.
Yeah. And here's the other thing.
Huh.
M87 has a mass of 2.7 trillion suns, which makes it one of the most massive galaxies known. You know how they talk about, I think our galaxy had like 400 billion suns or something like. This is a lot bigger. This is a real heavyweight guy.
Yes.
And that's why it's got that massive black hole in the center.
It does.
There's been plenty of mass to feed that guy.
Yes.
And,
now, we need to tell people how to find these things. So here.
Yeah, here's, it's a toughie. I'll admit it. It's good to have a chart, but remember the instar in actually Debnola, the tail of the lion?
Yes.
If you draw a line over to the star in Virgo, which is Vetra something or it's got a weird name, that one there. You've got the right star.
Okay.
It's roughly kind of between the two.
Okay.
And it's not easy. I mean,
so somewhere
you have
in
to
here.
kind of work at it. Yeah, in fact, that may be part of Markarian's chain right there.
Oh, there we go. It's right in
See,
the middle.
You got that? Yeah.
Yes.
That's what I usually stumble across first is Markarian's chain, and M87's not far from that.
No, it's down here.
The thing is, M84 is visible in 10 by 50 binoculars, according to some of the articles that I've read.
Wow, so I can see them in these guys.
Yeah, if those are 10 by 50s.
They are.
And you got to have a dark sky, get them while they're up high. My eyesight isn't that great, so
that's okay.
I have a hard time hunting them down. With my finder scope on my C8 is a 8 by 50 straight through finder scope, but and you can see there's no bright stars leading to it either. It's like in a void there.
No, I think I forgot to share my screen when we were describing it. So let me do it again, Kent. I think I was on the PowerPoint slide. Okay, sorry guys. So here we go. Let's see. Do you see where the Big Dipper is? Can you point to it? You point to the Big Dipper? Okay, great. Now we're old hats at old Big Dippers, right? Okay, so we're gonna arc to Arcturus. Okay, this was in that constellation that we just saw that one object was right above it. And then we're going to speed on to Spica or spike to Spica, whatever you like. And you speed on this way. So we are in the Big Dipper. We're arcing to Arcturus. That's our first stop. And then we are going to spike to Spica. And then while we're here, we are going to take a look at let's see if I highlight the Leo, you could see it a little bit better. Okay. All right.
Yeah, it's actually supposed to be like an arm of Virgo that's sticking out there for that one star.
Yeah. And so what we're going to do is we've got these. And so to find Virgo kind of has this parallelogram diamond shaped body. And it's got an arm right there. And so if we go between here and the tail of Leo the lion, here, if we bring Leo in, you can see Leo. If I connect the dots, do you see Leo now? We go from the tail of Leo to the hand here, and we go right in between, right in this area is where you want to be looking. And sure enough, we found it right there.
Yeah, when you find Markarian's chain through like an 8-inch, it stands out.
Yeah.
And, that's a unique pattern. You hit M84, M86, and then the next pair, I think they call it the eyes, but they're NGC numbers. That's pretty well the core, and then you just kind of drop down from that.
Yes.
And that gets you to M87.
Yes, it does. And we only have one more object, don't we?
Yeah, we only got one more, but it's a cool object.
It is a cool object.
It's M104, which is an edge-on spiral galaxy. It's got a great big halo to it. It's also got a nickname. They call it the Sombrero Galaxy, and that's probably due to some of the pictures from Palomar It kind of looks like a Mexican hat or the sombrero. And so the nickname, I have not been able to find the source of that nickname, but it has a visual magnitude of 8.0, so it's fairly bright. Has a diameter of 105,000 light years across. It's about 45 million light years away from us. It was discovered by Pierre Méchain on May 11th, 1781. It's also only 6 degrees off from being totally edge on. So it's, pretty close to being edge on. It also has a estimated 2,000 globular clusters around it.
Wow.
And I remember looking at a really nice picture of M104 and seeing all these very faint stars scattered around the halo of it. And then I realized those weren't faint stars. Those were globular
clusters
in the halo of M104. And it was amazing. M104 can be seen in 10 by 50 binoculars under good conditions.
Okay.
The dust lane crossing M104 can be seen in an 8-inch scope. And there is a way of getting there from the Stargate, which we talked about that a long time ago.
Oh, you guys are in for a treat. Kent loves to share his Stargate. It's not actually, it's Kent's own personal asterism.
Yeah, it's an asterism. For years and years, we just called it the triangle in a triangle.
Right.
And then an article came out in Sky and Telescope where someone called it the Stargate. And that kind of stuck from then on.
It did. Now, Stellarium doesn't have one of the stars, but that's because it doesn't have the ability to show you, as Kent said, an infinite amount of sky. So it's missing one of the stars. But let me show you. Kent, why don't you talk me through how to find it?
Okay, we start off with Corvus, the crow. That's a good place to start. It looks like a little square there.
Here, let me get rid of the... There we go. Okay. So we're here.
And you start in the upper right-hand star of the square, that one there. And when you blow it up, you'll see there's like a trail of stars going off to the east. And it goes, and then there's like a pair there, forms a triangle with one ahead. And... in front of that triangle, there you've blown it up way too much.
Too much. Yep. There we go.
Pull back, pull back. In fact, there's not bad.
Okay.
Right there. Again, start at the one star and follow the trail. And then there's like that triangle. There's those two. Yeah, there's the triangle. And that's not the Stargate, but then you continue on like you're shooting a bow out of that pair right there. That's actually the Stargate. And it's a triangle in a triangle. And I remember we were blowing it up, and you can see the outer triangle, and then you can see 2 stars in the inner triangle. But the third one, like Aurora was saying, you can't plot an infinite number of stars in these programs. So we're missing a star. But actually, in an 8-inch scope, you can see that other star that is there. So that's, it's an asterism. It isn't an open cluster or anything like that, but it's kind of cool. And also you can see off to the east from there's our Sombrero galaxy.
Yep.
It's not that far from the Stargate.
Nope. Here's your Stargate, and here's the Sombrero.
In fact, can you see that little arrow of stars above it that's pointing kind of towards? There's like 1, 2, 3, 4.
Yeah.
That actually is an asterism also called the Shark's Jaws. But I won't get into that because I don't know much about it.
That's okay.
So you can kind of see how it points right at the sombrero there.
It does. Here, so let's review just for a quick second here. Whoop, too far, sorry. Okay, so we are outside. We're going for a walk. We're looking south. Here, if I get rid of this, hang on. Let me shake up the sky. Okay, there we go. So we're looking south, and we're looking southeast. Tell me when you see Corvus. Do you see Corvus? We're looking, not you, Kent. I know you see Corvus. Okay, so we're looking for a box. Did you see it here? Okay, so we're going to grab that star, and we're going to look with our binoculars. So we'll see a binocular view like this, and then we're just going to follow this chain, and then we're going to get a bigger pair of binoculars. Okay, and we're going to follow this over, and then we see this guy. Is this right, Kent?
Yep. That's
Okay.
the bright triangle,
And then we're going to
and
keep
it points
going.
right at the little. It looks like a pear, but when you blow it up,
You see stars within triangles within triangles, and then you also see the sombrero real close by. And here's that shark's jaw that he just mentioned.
yeah, shark. It's part of what they call the shark's jaw. And I can
Yes.
kind of see it in real life, but
Yeah,
again, we're missing some stars
we
due to
are.
the graphics.
We are. All right, so real quick, let's find just the constellations themselves. Can you find me the Big Dipper? Yes. How about right there? Okay, good. Can you find me Spica? Okay, so we're going to arc to Arcturus and speed on to Spica. There it is right there. So this is going to be the wheat. And if you take a look, you can see Corvus is right next to it, right there. And then you'll be able to follow, like we just talked about, to M104. What about Virgo? Can you see Virgo here? If I blow it up a little bit more. Okay, so this is the wheat. This is her arm. Here, I'll give you a hint. There. Now we'll take her away. Okay, you see her arm here? And then do you see the other star we're interested in to connect? You see the end of the star? Okay, it's right there. So we're looking for this box. So this is a bigger box. Corvus is the smaller box. So the larger box here, we're going to go off here to, you see 3 stars in a row, 1, 2, 3. We're hang on to her hand here, and then we also find the tail of Leo the lion. We go right in between with a pair of binoculars. We're going to be able to start to see some fuzzy little blobs. And what was this again, Kent?
Oh, that's Markarian's chain.
Markarian's chain.
With
and
M84 and then M86.
M84.
And the next two beyond that are called the eyes.
Yes.
I have no idea why they call them the eyes, but those two are called the eyes. They've actually all got their own little NGC numbers.
Yes. And so you can see all of this just by taking a look at the night sky tonight. So we already went through, for those of you who missed, I saw a bunch of questions about M51. Real quick, if you just find the Big Dipper and you go off the handle, see if I can not make you dizzy. Sorry. So we've got the Big Dipper, and here's the handle, and you just go straight off the handle, and you'll be able to see M51 in this area here. Okay, and then the hunting dogs. That was the last one or the first one we covered. So the hunting dogs again. You go off the Big Dipper. Big Dipper is a great pointer for a lot of things, isn't it?
Oh yeah.
Yeah. so we'll go off the handle here. We're gonna go to this first bright star. This is the brighter of the 2 hunting dogs, and this is the other one. And then we can even continue our line here from the handle through the brighter of these 2 stars, and then continue to this bright star, which is the tail of Leo, the lion here. And right in between the brighter dog and Leo's rear end is the open cluster that Kent was talking about before. And right under that open cluster, Kent, what did we look at? We saw something right under it.
Yeah, we had NGC 4565.
Which is right there.
Beautiful edge on galaxy.
Yes, right in there.
You know, it's well worth it to go to your higher powers once you have it centered up.
Yes. And you did it. We did it. Yay! Okay. I never knew the shark's jaw. Thank you to see. Okay. Thank you for that. What does relativistic mean? So we're just going to take like 1 or 2 questions. So this one has been in the queue for a little while. So Kent, do you have a quick?
Yeah, I can answer that.
You want to answer that one? Okay.
Relativistic means the jet. We talked about this relativistic jet blowing out of M87, and you had a picture where you can see blobs coming out of there. Those are going close to the speed of light. When you start seeing relativistic effects like times and change and mass, that's what they mean by a relativistic jet. It's really up there. I mean, you can't reach the speed of light because then the jet would become infinitely massive, and there's just not enough energy to do something like that. But it's up there. It's probably like 90% or 95% the speed of light that's blowing out of there. I'm not sure. I'm just making up those two. I don't have an actual number for you, but
sure.
You have to get fast enough to start seeing the Einsteinian weird stuff start happening.
Yes.
And that's what is happening with that jet. There's so much energy in that rotating black hole that it's able to accelerate. And this is probably the pole, like the North Pole of the black hole, it has a bunch of material falling in, and there's weird hydrodynamic pressures that happen.
Mm-hmm.
And so, this stuff hasn't gotten within the what's that point of no return on a black hole?
Oh, the event horizon.
Yeah, event horizon.
Yeah.
But it's probably riding above it, and the pressure just squirts out this jet right along. And there should be another jet on the other side.
Yes.
South Pole blowing out
Yes.
from the same material. Accretion disk, that's what they call the material that's in orbit and eventually falling into the black hole.
Mm-hmm. Yes, and
so
I
hope that makes some sense.
Yes, that was perfect. Thank you. I should clarify. Alex McConaughey took the pictures here. This was taken by a telescope that was in space. So this picture that you got down here. So yes.
I do have a real quick story at the Texas Star Party.
Sure.
On the upper level, they had a 36-inch scope, what they called the yard. I think it was called the yard scope.
Okay.
And it gets pretty dark there at the Texas Star Party. It's over near, I think it's Fort Davis.
Uh-huh.
And the guys were actually able to see that jet.
Whoa.
Naked eye blowing out of but it took a 36-inch scope to be able to do it. So it has been seen by amateurs.
On the ground. That's amazing.
Yeah, on the ground. You didn't need a Hubble. I'm sure it was not an easy observation.
No.
But,
I'm sure.
36 inches, that's pretty good for an amateur scope.
Yes, that's amazing. That's amazing. I can answer this one real quick. We had a number of, it looks like equipment recommendation questions like, hey, this is great. I want a pair of binoculars. I want to get a telescope. What do I do? You print out our handout and look on the very last page. And this has all of our equipment recommendations and have fun with that. So it's for kids, grownups. And so our basic information is there. So you can take a look at that. Okay.
I've got a nickel to throw in there. If you have a Big Five anywhere in your area, which is a sporting goods store, those, Big Five has really good sales on binoculars. You should be able to get a nice pair of binoculars for somewhere from $25 to $35.
I totally agree. Yes. You should not have to spend $200.
Is a good outlet.
Yeah.
You don't have to spend a lot of money on,
for a good pair.
Yeah, for a decent pair of binoculars.
Yeah.
You just make sure when you look through it that both images coincide. If both images don't coincide, the binoculars have been dropped, and it costs a fortune to get the prisms realigned.
Right.
So you do not want binoculars where the images don't coincide when you look through the two eyepieces.
Not at all. And I actually had a couple of quick member shares if you want to see a couple. We have one of our astrophotographers, longtime astrophotographer. He was doing it back when it was all film. He actually was published in more than 1,000 publications. Dr. Lee Coombs, retired chemistry professor now from Cal Poly State. He has been, Brian, if you're there, he gave you some images for the store as well. Is that correct?
Yes, we have quite a few of his images that are on T-shirts.
Oh, awesome. And you also have pictures do you have pictures from Nikolai?
I do. I have an Andromeda Galaxy picture from him. His are on various mugs, including travel mug and even water bottles.
Oh, nice. Okay, great. So so we have a number of there's Brian. So we have a number of astronomers. Here's another picture of Brian. He has been doing a bunch of astrophotography. He actually did our live views, which is a whole different animal, right, Brian?
Yes, indeed.
Yes, it is. And we're going to be doing that again in the future, just maybe when it doesn't get dark quite so late. We'll be doing that.
And we will have, weather permitting, the live view of the moon on June 15th.
Yes. Yes, that'll be really neat. On July 15th, you said?
June
15th. Okay, yes. Great. Okay, great. And then we had also images from Peter Bressler. He calls himself an amateur, but not just an amateur. He calls himself a beginner. But the images he has been taking, I know. Look at that telescope. That does
Look
not.
at that scope. I mean, look at the stuff hanging off of that scope. Look at the mount on that scope.
Yes. So, Peter, this is a shout out to you. You are amazing. Keep up the amazing work. And so so you're not a beginner. So we appreciate all the images you give us. And we also have Alex that you met at the beginning. He has been, Brian, you know more Alex more than I do. He has been doing astrophotography for a long time, hasn't he?
Yes, very long time. Very active in astronomy outreaches also.
Yeah. Okay, great. Well, I just wanted to give a quick shout out to all of our members. And if you enjoyed tonight's presentation, please drop us a note in the comment box. You can send us an email to questions@centralcoastastronomy.org and let us know how you enjoyed for tonight's presentation, specifically what you really enjoyed most, so we can do more of that. And I do have a correction. Thank you, Brian. How do you say booties? It's not booties, it's Boötes, isn't it?
I call it Boötes, but
Boötes.
I mean, the O can be pronounced, as a long O, Boötes.
All right. And Brian.
I'm sure I've butchered it for like 40 years.
That's all right.
Does. And by the way, this would be a good recommendation for the book Night Watch.
Yes.
It actually has a pages full of pronunciation guides.
Nice.
And so it is Boötes is the official recommendation.
Boötes. You got that, Kent?
Yeah. Boötes. Okay.
Boötes. Okay, great. And then the sky map. Thank you, Brian, for correction. This is at skymaps.com. Skymaps.com. And I'm sure you would have figured that out anyway when you didn't get to the right site. But just so you know. So, okay, great. Do we have any other last minute questions, Brian? If not, we're going to go ahead and wrap things up. What do you think?
No last minute questions.
Okay.
I'd just like to mention the store one more time. Really
Please
quick.
do.
Yeah, remember we have our brand new Central Coast Astronomical Club store. And I mentioned we have t-shirts from Lee Coombs, but we have t-shirts, coffee cups, water bottles, and all the images are from Central Coast Astronomical members. And to get to the store, go to our website first, centralcoastastronomy.org, and you'll see that button right on the right-hand side for Club Store. And if you see, is there a different object you'd like to see on a shirt, let us know and we'll hit up our club members. Or another kind of object, when you browse around Zazzle, you'll see they have many different kinds of items. So we can expand the products in our store if you like. Just let us know. Remember, the questions at centralcoastastronomy.org email address is always monitored. So you can hit us up anytime with that.
Awesome.
Thanks.
Well, thank you. Thank you, Brian. And I mean, how cool is that? You can tell us what objects you want us to go image, and we'll tell our astronomers, and they'll take an image, and then you can pick what it goes on. I mean, how that is like custom. All right, we need to wrap things up. So Kent, as always, thank you so much for your expertise and for sharing your time with us and your knowledge and passion for the night sky.
You're very welcome.
I have definitely enjoyed learning from you for all these years. I've known Kent for about 15 plus years now. So thank you, Kent, for taking time with us. We had some people that were asking why we can't see Kent. It's because we were so busy showing you the night sky. So, and Kent is actually just calling in by phone. So that's how.
At least it's not a rotary phone any longer.
It's not a rotary phone. So Kent used to Kent used to call in by rotary phone, which, as you know, we're patching him through on Zoom. Well, he couldn't dial in anyway, you get the picture. So it was a little bit of a challenge. So thank you so much, Kent, for tonight. And also, Brian, I'm swinging around to you. Thank you so much for joining us tonight and moderating.
You're welcome. Thank you.
And thank you to Alex. Alex, I know you're not here. You're already signed off, but thank you as well. And thank you, audience, as well, for joining us. And all the astronomers that have been busily typing, like Tom Smith I saw was on there, and I missed a couple more. But all you astronomers who were busy answering questions for our audience, thank you, thank you, thank you. I will see you guys next time. We have our next stargazing is in July. Is that correct?
June.
I'm sorry. Look, I'm already ready for summer. Look at this.
Yes.
It's the second time I've done this. Okay, so do you have that date by any chance?
I do. The virtual stargazing will be on Saturday, June 12th.
Okay.
And then following that Tuesday, June 15th, will be our special live moon two were with Dr. Lee Coombs.
Oh, wonderful. So we'll make sure you're on our website, on our email list.
Yes.
So go to our website, www.centralcoastastronomy.org, and then you'll get the reminder emails that say, hey, go here. It's happening tonight, that kind of thing. So we'd be happy to have you as part of our family. All right, everyone. Thank you, Kent. Thank you, Brian. And we will see you next time. Take care, everybody.
Thank you, Brian. Thank you, Aurora.
You're
Goodbye.
welcome. Bye-bye.